Okay, our OR statement, and here's our picture. Not panning for OR, gold, or like this is possible, or that one's possible. So let's look at this right here. First off, I'm going to look at each side individually. Let's look first off at just the left. I just got to add 7 to each side. So x is less than -4. And over here, I guess what I'm going to do. I'm going to add 7 to each side. So x is greater than 2. So let's go to my number line. I have a -4 and a 2. Notice the -4 has got to be a closed circle. It's a dot. The 2 is going to be open. There is no bar. Wait a minute. The 4, x is going to -4, x is small. It's going to shade this way. This open circle here is going to be here. And now x is larger and it shades this way. Now here, because this is an OR, it means it can be true if this one's true or that one's true. So it's shaded opposite. Most ORs are shaded opposite. Doesn't have to be. All right? But most of them are, because if it's true in either one, it's true then for all. In the AND, it would have to be true. If this had been an AND, the answer would have been no solution, because nowhere do they overlap. Now, something I want to point out, this is not the problem, but suppose the sign had been flipped. Right there. Notice it's different. The answer is still the same. So this time x is less than 2 instead of greater than. So when I go to graph it, the -4 one didn't change, but the 2 one, instead of going this way, goes that direction. And if that happens, well, if it's an OR, basically that's my answer, except I can go ahead and take the big dot off the -4. If you leave the big dot on the -4, I'm not counting it wrong, because that was part of the solution, but there's not necessarily a need for it. All right? So that would be the best answer like that, because an OR means it's true in either one. Now, most ORs will look like that one. That would be your typical OR, but they don't have to.